My name is Gera. I work currently as a distributed systems engineer at NVidia. My team works on GPU acceleration of Apache Spark, a popular kind of big data uh, Swiss knife kind of toolkit for um, uh, data processing, machine learning, some graph algorithm, and so on and so forth. Understanding the system end to end, which includes the hardware, helps you as a professional to come up with the best possible solution. And it doesn't mean that you have to invent a new hardware, but if you know the system from the user and a type of interfaces from the graphics UI to web APIs to operating system calls to the hardware you're using, the better you are in your job. When my advisor approached me with an idea that I can stay for a PhD to work on my next level PhD thesis and kind of also gave me a taste of what it can be like going attending international conferences, publish papers, uh, and participating in the cutting edge research. I kind of grabbed that opportunity and did it, and it's helpful, but it doesn't mean it's the only way. Especially, I think in the US, it's absolutely not. It's again, it's helpful, but it's not required. So if we want to have a good career in our industry, startups provide a lot of opportunities for an individual to shine and to contribute very significantly to the success of the company. On the other hand, when you're at a startup, it usually revolves around one bright idea, one excellent opportunity. Hopefully, uh, there is a roadmap how to scale that opportunity and capture the market, the world, whatever, expand your niche. But everything else is not. It's pretty immature. So the infrastructure. Um, you will, if you've seen it before at a kind of well-oiled machine like a big company like Microsoft or Oracle, will not be there. If you have um, an inclination to do to describe work in formal terms like a math problem and understand that things need to work correctly conceptually before you even build them. This is a very important skill and to kind of grasp problems abstractly before you dive into little details. People choose open source projects for something that are that represent a cause they care about. Uh, the the others choose it just for their new milestone education. They want to pivot into some new field, and obviously their current resume doesn't necessarily uh, is telling recruiters that they can be good in this subject. Absolutely, I think this should be at least 50% of the evaluation, if not more, because as I said, the um, actual interview gives only a tiny glimpse on how the person works on a very artificial problem that probably will not be very common in your company or in their actual job. Our technical field, I think it's very important to have very clear communication, have demonstrate reasoning, to be honest about situations where you simply don't know, and just explain your thinking process, because there's no, it's not binary. It's not about necessarily working on exactly literally our narrow field. It's exactly about, okay, was it a complex problem? Was it difficult to do? Did they demonstrate success? And can I find traces of it? Look, if the item on the resume uh, quotes some open source work, I will look at the traces there, like how significant were the contributions, as were they as significant as claimed. It probably the recruiters will also look, okay, if somebody talks about a smashing success for some project, like was it followed by promotion? This is where the academia is very helpful, to see everything as a combination of fundamental concepts that come together in a bunch of applications and industries. So you don't necessarily stick to some um, very particular technology with a very particular vendor that may indeed disappear. Uh, and as long, even if it happens, as long as you are good in it and demonstrate that you can learn, acquire additional. So this is the only thing you know, and then you're still a good candidate for other opportunities for other startups. I mean, yeah, bearing with kind of now new, more revolutionary disruptions in the computing industry, like maybe quantum computing, which maybe works very different. The rest, like the majority of the industry, midterm is still, again, just the same a bunch of same bunch of data structures, same bunch of algorithms applied just to a different use case. Do as many internships as possible during the studies still at school, because it's a great way to try it before you buy it for both future employers and future candidates. Kind of nothing is final in this, which is great for our industry so far, has been that it's relatively easy to switch um, careers despite the periodic downturns in the market. Overall, we still enjoy high demand for our skills.